All right, hi guys. Today we're doing day 3, block 1. We're going to continue looking at some parallel lines here. So for these first few problems, we're looking again at those crook problems like we talked about yesterday, where you have your two parallel lines and then instead of just one transversal, you have some crooked lines in between them. So let's start with number 1. It says find the value of x if A is parallel to B, so we can put in our parallel symbols here. And we're looking for x down here. Now yesterday we said the best strategy to do these would be to add in more parallel lines at each bend in the crook. So I'm going to add in some straight lines, holding down the shift key if you're on Cami with me. And those will help us use our different rules with the transversals and the different congruent angles so that we can find more information. So for example, this first section, 115 right here, I also know that this angle is 115. So then I have this straight angle here. So I can figure out the measure of the missing piece of this first straight angle. So I'll do 180 minus 115. And that tells me that just this portion here is 65. Now if I look at the middle part, I have another transversal going the other way. But I also have this 90-degree angle here. So I know the red angle up top and this little blue angle should equal 90 degrees. So I have 90 minus 65, making this little one 25 degrees. And then following that transversal that's in the middle, we're going to ignore the 40 for just a second. It's hard sometimes to get a little confused. You have to remember the 40-degree angle is this whole piece, but I just want this little portion of it. And that transversal here tells me I can use alternate interior, so the small portion is 25. Now to figure out the missing small portion down below, again I know the total would be 40, so I'll subtract 25, which leaves me with 15 degrees. And then finally, my last transversal gets me back to that x angle I wanted at the beginning, alternate interior, so x equals 15 degrees. Again, it's like putting together the pieces of a puzzle, just doing it one step at a time. They're not really problems where you just look at the picture and you know the final answer. You got to work your way to what you're looking for. So let's look at a similar problem. We'll get you set up here and I'll see if you guys can try this one. Same idea, now our parallel lines are just going the other way. Here's our parallel symbols. So what I would encourage you to do, draw in more parallel lines at the bend. So here, and then here, about there. And I want you guys to try this one on your own, see if you can figure out the value of x. All right, here is my final answer for that problem. X equals 120 degrees. So I started over here on the left. I have alternate interior, so this little angle is 15. 105 minus 15 gives me a measure of 90 degrees. The bigger portion, I should say, of the x angle is also 90 because that's our same side interior. Those are supplementary. In this case, they're also congruent because 90 is supplementary to 90. And then I know from the alternate interior over here that this one's 30. So for all of x, I added them up, 30 plus 90 to get 120. Okay, and then number 3 here, another parallel lines problem. So let's set up what we know here. Line P is parallel line Q. We're looking for x and y. So I see a couple different things. I see this straight angle up here. Since I have x and y, I'm probably going to be solving a system. So I know 10x plus 4y should add with 18x minus 7y to equal 180 because it's that straight angle. I'll simplify this guy a little bit. So 10x, that gives me 28x. 4 minus 7, negative 3y equals 180. And then I also notice that I have an alternate interior set up here. So this angle and this angle should be congruent. So I can say 10x plus 4y should equal 6x minus 2y. I'm going to get the variables on the same side here. So I'll subtract 6x and add 2y. So I have 4x plus 6y. Now be careful, sometimes when we get confused, when everything on one side disappears, we still have to show that, so that actually equals 0. So now you have your two equations, and then I want you to finish solving this system on your own. All right, so here is the rest of my work. So solve the system, I used elimination. I multiplied that first equation by 2. You can see the work down here. Add them together, I got x equals 6. Plug that back in. I plugged it into the second equation I found, and I solved for y, got y equals -4. Okay. All right, so the rest of our notes here are a bunch of proofs. So we'll work through some together, and then I'll give you a couple to do on your own. So let's take a look at this first example here. So as always with proofs, we have our statements on the left and our reasons on the right. And our very first statement, even before I read any of this or decipher it, I just like to get in a good habit. I'm going to copy down the givens. So we have that line L is parallel. Here, I'm going to write the L in cursive. Parallel to line M, and angle 2 is congruent to angle 4, and that's given every time. So once I write that, then I go back to the picture and I like to label whatever that information is telling me. So these are parallel. Angle 2 and 4 are congruent. So this angle here is congruent to this angle here. And then looking at what we want to prove that angle 4 is congruent to angle 3. Okay, so one of the easiest ways to start is using the given information. What else can I conclude if I know that these lines are parallel? Let's start there. When I look at this picture, I see right away this alternate interior situation. So I'm going to say angle 2 is congruent to angle 3. The reasoning for that is just alternate interior angles. Keep it simple there. Okay, well, I already said 2 is congruent to 4, and 2 is congruent to 3. So I'm already ready to jump down and say, well, then 2 also has to be, then 4 also has to be congruent to angle 3. Okay, because both of them are congruent to 2. And that comes from my transitive property. So I'm done. That's it. Pretty easy one. Let's look at the next one here. So I'm going to write S and R because I'm being lazy. So we have that line J is parallel to line K. K is parallel to line L. And that is given. All right, so let's take a look at what that means. So J is parallel to K. K is parallel to L. Okay, so right away, even just labeling it, I already know what my next step should be. Since J and K are parallel, K and L are parallel, I feel like it makes sense to at least say that J must be parallel to L. And again, that's our transitive property. So that works for congruence and parallel as well. So all three of those lines are parallel. Now let's see, we want to prove angle 1 is congruent to angle 3. So that's my goal here. Well, just from that transitive property alone, I feel like I'm already ready to say that they're congruent. I don't think there's much more we have to do for this one. So 1 and 3 congruent to angle 3. And the reasoning there would be that those are corresponding angles. You could also take a couple more steps here. Instead of using the transitive property for the parallel, you can use the transitive property by saying that angle 1 is congruent to 2 and saying 2 is congruent to 3 because of the parallel lines given to us, and then transitive property from there saying that 1 is congruent to 3. So either way would work. All right, we have two more proofs on this set of notes, I want you to try them both on your own. I'm going to leave up number 3 first, and then you'll try number 3, play the video to check your answers, and then I'll scroll down after I explain it to number 4 for you. All right, let's see how you did with this one. A little bit different here because we're trying to prove that these two lines are parallel. So just be careful keeping that end in mind in terms of what you say and what you already know. So I have my given statements first. And then because G and H are parallel, I said angle 1 is congruent to angle 3 because those would be considered corresponding angles. And then from there, I can say that 3 is congruent to 2, or if you wrote 2 congruent to 3, that's fine. The order doesn't matter there because of the transitive property. Since 3 and 2 are both congruent to angle 1, that means they're congruent to each other. So if angle 3 and angle 2 are congruent, that has to mean that P is parallel to R because it's like going in the reverse direction. We're saying that since they are alternate exterior angles, then those lines have to be parallel. So these lines are parallel to each other. For your last statement, or sorry, your last reason, if you just wrote alternate exterior angles, that's fine. I'll take that. I wrote it as an if-then because we haven't really used it in this way yet. But either way is fine with me. Okay, so then the last one here, I want you to try number 16 on your own. All right, so my last proof here, I like this one. It's a nice one to end on because I think it's pretty straightforward now that we've done a couple of them. So I have 2 pairs of lines being parallel, so I rewrote that for my given statement. I'm trying to prove that angle 1 is congruent to angle 3. So I kind of have to work my way over. Proofwriting kind of reminds me of like those crook problems. Like you can't just jump from the beginning all the way to the end, the final answer. You have to really build up each step, one step at a time. So I don't really worry about, well, how is 1 congruent to 3? I just think, well, what do I know about these angles? And I see right away, well, 1 and 2 have to be congruent because they're alternate exterior. And then I notice, well, 2 and 3 should be congruent because those guys are corresponding. And I can see nicely the transitive property. Angle 1 and angle 3 are both congruent to angle 2. So that means they're congruent to each other. And that's what I wanted to prove. So I am done.